So we're talking about geometric proofs today. So we did algebraic proofs last unit, and it gave us an equation, and we did the steps to prove the answer. Today we're going to look at different triangles, and it still gives us information, and we're trying to prove that they're congruent based off of those 5 theorems and postulates that we talked about yesterday. So you're always going to start with the given, just like our algebra proofs, and then we're going to do what we got to do, and then our last line, of course, should be our proof, but our reason for that is going to be one of our 5 from yesterday. So it's either going to be side, 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 angle, side, angle, side, angle, 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 side, or hypotenuse, leg. Okay, and that is going to be our last reason. Alright, let's do one. So we set them up the same way that we set up the algebra one. So we've got statements, and we've got reasons. Okay, so we always start with the given. How many things are we given in this? 3. So we're given AB is congruent to DE, we're given BC is congruent to EF, and we're given angle B is congruent to angle E. So our first 3 things are given. Okay, so the first thing we're given is that AB is congruent to DE. And again, that's given. Okay. Then we're also given that BC is congruent to EF. That's also given. And then we're also given that angle B is congruent to angle E. Okay, so we're given all 3 things. If I look at my picture, it's already marked. So AB is congruent to DE, BC is congruent to EF, and angle B and angle E. Do I have enough to assume congruence? Yes. By what theorem? Side, angle, side. Good. So we're done. So then our last thing is what we're trying to prove, which is triangle ABC is congruent to triangle DEF. And we know that because of the side angle side theorem. And we're done. Some of them, yeah. Any questions on that? So that was pretty easy. It told us everything we needed to know. Let's look at this second one. So on the second one, again, we're given PQ is congruent to TU, angle P is congruent to angle T, and angle Q is congruent to angle U. So again, we're given 3 things. So our first 3 things are givens. So first we're given PQ is congruent to TU. Then angle P is congruent to angle T, and that's also given. And angle Q is congruent to angle U. So, based on these three things, do I have enough to assume congruence? Yeah, based off of what theorem? Good. Angle, side, angle. Very good. So then I'm proving that triangle PQR is congruent to triangle TUS. And we said that was because of angle, side, angle. Questions? Okay. So these two gave us everything that we need, but that's not always going to be the case. So let's look at this next one. So this next one, we're given that C is the midpoint of BD and AE, and we're trying to prove that these triangles are congruent. So let's write our statements and our reasons. So you can write your given as one long thing. C is the midpoint of BD and AE. But I'm going to split it. So I'm going to say C is the midpoint of BD and C is the midpoint of AE. And those are our givens. So C is the midpoint of BD and C is the midpoint of AE. And those are given. Again, if you want to write it as one long statement, that's fine. It don't matter, really. So, what does it mean for something to be a midpoint? What is a midpoint? What is it? Yeah, so it's in the middle. It's halfway between the 2 points. So if it tells me C is the midpoint of BD, what does that mean about the side BC and the side DC? They equal each other. Good, because C is in the middle. So that's the next thing we want to say. BC is congruent to DC. And we knew that because it told me it was a midpoint. So our reason is definition of midpoint. Okay? So that's what it means when it says something is a midpoint. It means it is in the middle, it's cutting it into 2 equal pieces. Yes, yeah, so then our next thing, it tells me C is the midpoint of AE. So same thing for this one. AC will be the same as EC. So that's what we want to say next. So AC is congruent to EC. And again, the same reason. We knew that because that's what midpoint is. So definition of midpoint. Good. So in these, we need three things to be congruent. We only have two. We have two pairs of sides. But if we look at this in the middle, here and here, what are those? Vertical angles. So that's the next thing that we want to say. So I don't want to say just angle C and angle C. So I'm going to say angle ACB and angle ECD. So angle ACB is congruent to angle ECD. And that's because vertical angles are congruent. So you already have all the knowledge for these proofs. You're just putting them together, kind of like a puzzle. So now, do I have enough info? Yeah. By what theorem? Good. So we've got side, an angle, and a side. So side, angle, side. Good. So triangle ABC is congruent to triangle EDC by side, angle, side. Very good. Any questions on that? Alright, so our next one. So our next one, we're given that AB is congruent to CD. We're also given that BD is a median of AC. You might know what a median is. So a median is a line that connects the vertex of a triangle to the midpoint of the other side. Okay, so median does the same thing as midpoint. So that's telling me that D is the midpoint, is pretty much what it's saying. So let's write it out. Okay, so the first thing it gives us is that AB is congruent to CB. And that's our given. Okay. Then we're given that BD is a median of AC. So BD is a median of AC. Okay. So if we mark over here on our triangle, we know AB is congruent to CB. We already wrote that. And then again it tells me BD is a median. So that means it's connecting B to the midpoint down here. So then what does that mean about AD and CD? Yeah, they're congruent as well. So let's write that. So AD is congruent to CD. And we know that because that's what a median does. So definition of a median. Okay. Oh, sorry. Definition of median. So if we're looking at this triangle, what else do we know about it? Yeah, they share this side right here in the middle. So that has to be the same because it's the same thing. So we can say BD is congruent to BD. And so I know it's been a couple weeks, but remember when something equals itself, that's called the reflexive property. And instead of being a property of equality, now it's a property of congruence. So POC. So property of congruence. So now, can we assume these triangles are congruent? Yes. By what theorem? Good. Side, side, side. So triangle ABD is congruent to triangle CBD. By side, side, side. Questions? All right, let's look at our next one. Okay. So the first thing we're given is angle G is congruent to angle I. And that is given. So G and I. The next thing that we're given is FH bisects the angle GFI. What does bisect mean? Good, it cuts it in two. So it cuts it into two equal pieces. Good. So then if I'm looking at that, FH bisects GFI. So GFI is this big angle over here. So what that means, when it bisects it, it cuts it into two equal pieces. So that means the top of this angle is congruent to the bottom of the angle. Okay. So then to write that, I can say IFH is congruent to GFH. So angle IFH is congruent to angle GFH. And we know that because that's what it means for something to bisect something. So that's the definition of an angle bisector. So, what else can I say just by looking at these triangles? Yeah, so they share the side again, so we can say that FH is congruent to FH. And again, when something equals itself, that's reflexive. Property of congruence. Now, can I assume that my triangles are congruent? Yes. By what theorem? So we got an angle, and then we got an angle, and then we got side. So angle, angle, side. Good. So triangle GFH is congruent to triangle IFH by angle, angle, side. Good, good, good. Any questions?